Okay, so let's go into this. This is a really important application area for computer vision. And the reason being is that self-driving, I mean, traffic in general, self-driving can save so many lives and can save human time. And that's really important. So for example, somebody correct me if I'm wrong, but I know this information that in San Francisco, for example, that the average transit time, the daily transit time is like 3.5 hours. So like somebody calculated you lose I don't know how many years of your life just traveling around. So self-driving can help with this thing, and it relies heavily on computer vision, on cameras and stereo vision. Okay, so there is this device called LiDAR, and it's something similar to radar. It's just that it works in the light part of the EM spectrum. And basically, like Elon Musk is against these devices. They are pricey and stuff. L4 companies, where L4 means almost full autonomy, they want to use this device LiDAR, but nobody, sorry, but nobody disagrees that we need to use vision. We need to use cameras. And the reason being is that the roads were designed for human eyes, and we pretty much use vision, right? So here you can see a lot of information that can be extracted from an image, from video, and like here you can see road tracking, bounding boxes around cars or pedestrians. We know the depth information. We can see the signs here, and we know the semantic meaning of these signs. And using all that information, we can plug it into control and planning software, which is a layer above the perception layer that the computer vision provides you, and we can drive the car. So there are two parts to this self-driving problem. One is to sense the outdoor environment, and the second part is to sense the indoor environment, driver and passengers. So when it comes to outdoor sensing, so here you can see the example of panoptic segmentation, and just a fancy name for this. So you basically, whatever pixel you see in the image, you want to associate with it certain class. So you know, for example, this pixel here belongs to sidewalk, this one belongs to pedestrian, this is a car, road, etc. So let's see a quick video here how it looks like. This is a real visualization from this company. Let me just play it. So you see how it looks like in real time, extracting it from videos. And I think I have another here. So here we can see a lot more information, not just the panoptic segmentation. We can see, well, let me just play it. And as you can see here, it's tracking the lanes. It knows exactly in which lane it belongs to. It knows where the cars are, and also the depth information. It knows how far off a car is, so you can brake or accelerate accordingly. So that's the outdoor sensing and in self-driving. So the second part, really important, is indoor sensing. So you want to do multiple things here. You maybe want to figure out if the driver is maybe tired or not focusing on the road, say talking with a passenger or looking at his or her phone. And using these algorithms and computer vision, we can figure this out and maybe, I don't know, maybe warn the driver or even stop the car depending on the context and the situation. So let's look at a short video here. So you can see here, this guy, we're just like tracking his eyes and his head, and using that information, we can kind of try and extract gaze. Because this is really constrained environment, I guess we can pretty successfully extract the gaze information and know if the driver is focusing or not focusing on the road. And here is this really awesome video. This guy called Lex Friedman. If you're into AI or computer vision, I suggest you like go and check this guy out on YouTube. He's called Lex Friedman. And here you can see we are not only figuring out if the driver is focused or not. This guy is obviously not focused on the road. He's holding a guitar, and you can see here, I hope you can see here, like the network says with a high confidence, like 88%, that he's holding a guitar. And let me just show you what will happen now. Whoa, like Betty, bam, bam, whoa. hope you saw that part here. So now, as he took water bottle there, the confidence just bumped up to 99%. So it's working, and it's still holding guitar. So you can imagine once you have this information about the driver or about the passengers, you can do lots of cool stuff. And how it did that, this is they have RGB camera, and they just do optical flow extraction here, and they train some neural network models to do this stuff. And also, I didn't mention here, but like it's also following the roads and lanes outside, but the goal was to focus on the inside sensing here.